As we know, the motorcycle is one of the most common vehicles used in our society, and sometimes we don't have an idea of how some of the elements of this vehicle are made. In this challenge, we will talk about two pieces of the motorcycle and some of their characteristics and manufacturing processes. In this case, we chose a Kawasaki model as base, and the selected pieces were the connecting rod and the piston. First, we will talk about the connecting rod. We found the dimension of the connecting rod as we can see in the sketch, where each letter represents a specific part of the connecting rod. Also, we found a table with mechanical properties that are very important to establish a correct engine. So it is important to consider some elements such as the density and the position radio. In addition, we did a search about the production quantity, and we determined 750 pieces were enough to produce per day in both cases, for the piston and for the connecting rod. Also, to manufacture a connecting rod, we need to take into consideration some design requirements, such as the joint surface flatness, bearing crash, geometric shape, and cap screw torque can significantly affect bore distortion, assembly stresses, and bearing and joint load distribution. Similarly, it's important to highlight the methods for the production of these pieces, and after making a research, we found some methods to make a connecting rod. The first one is closed die forging. One of the advantages of using closed die forging is that it's suitable for metal materials. One of the disadvantages is that it has a size limitations. The next is the roll forging. In the case of roll forging, one of the advantages is that it increases the strength and hardness of the metal, and one of the disadvantages is that it has high cost. Finally, in die casting, one of the advantages regarding die casting is that it has high productivity, but one of the disadvantages is that the dies are very expensive.
From these three methods, the one that we think will be the best option is closed die forging.
It is also important to add the different possible materials for this piece, being possible the use of steel, aluminum, and titanium, being the best option steel, because aluminum rods need many revisions, and on the other hand, the price of titanium is very high and not optimal for this type of production. Steel rods can be cast or forged. Cast ones are okay for stock applications, but are usually a bad idea if you are interested in significantly increasing the power and torque output of your engine. Forged rods offer a superior grain structure within the metal, which becomes far more coherent thanks to the large pressures exerted on the rod during the forging process. While aluminum rods follow this process, using casting as their most optimal option. Titanium has been successfully forged by the open die method, using conventional equipment designed for steel, but with lower temperatures and increased pressures. Because of the lower temperature, it becomes necessary to use higher pressures to deform the metal. For the connecting rod, the best is to give some annealing treatment after the forging process to relieve residual stresses, to increase ductility, as well as to improve machinability and dimensional stability. No surface treatment is required. The forging force is calculated using the next formula, where K is a multiplying factor obtained from the book. YF is the flow stress of the material. A is the projected area of the forging, including the flash area. In this case, the area was found on internet. The forging operation produces flash, and it is considered a complex shape. The forging temperature of steel is approximately 1000 degrees Celsius, so the flow stress is 356 megapascals approximately. Finally, we have the next result.
As we mentioned, the second piece chosen was the piston, and we can see the sketch with the mechanical properties of the piston of the three different types of aluminum alloy, where we can see some of the properties such as the elastic modulus and the Poisson's ratio. Now, for the next part, the piston measurements are shown. These values are an approximation, and the value of each part is mentioned in the following section. After that, the piston must have some design considerations to work properly, like the fact that an enormous strength is needed to withstand the high pressure, and the piston needs to have a minimum weight to withstand the inertia forces, and it is necessary to provide sufficient bearing area in order to prevent underwear. But we can see some other design considerations for the piston. Also, we made a search about a possible method for the piston, and we concluded that the piston can be created with closed die forging and casting, where some pros and cons are involved. In this case, the best option is to use closed die forging. As you can see in the slide, one of the advantages of using closed die forging is that it is capable of producing products with higher strength. One of the disadvantages is that it needs some machining after the process. For the casting process, one of the advantages is the possibility of casting any material, and one of the disadvantages is that it has less mechanical properties than the forging process. There are many variations for the manufacturing pistons. For example, we can mention cast iron, alloy steel, and aluminum alloys. Aluminum alloys are distinguished by good formability during casting and good machinability. These alloys are characterized by their low hardness and strength indices and elevated temperature. In some cases, these alloys are reinforced with ceramic materials to develop new composite materials. For pistons, it is recommended to heat the forgings twice more. The first one to strengthen the metal, and the second time at a much lower temperature to stabilize the internal structure of the piece. Machining is also required. The forging force is calculated using the same formula that was used in the previous part. For this case, the forging operation does not produce any flash, and it is considered as a simple shape. The forging temperature of aluminum is approximately 428 Celsius, so the flow stress is 35 megapascals. The area was calculated in SolidWorks, so the result is the next one.